Magnets have captivated human curiosity for centuries with their invisible force and unique properties. But how do magnets work, and why do they inherently have a north and south pole? At the heart of magnetism is the concept of the magnetic field, an invisible force field that exerts magnetic force on substances susceptible to magnetism. Magnets are composed of materials such as iron, nickel, and cobalt, which have an atomic structure that allows for magnetic properties to emerge. Atoms in magnetic materials have electrons that spin in particular directions, and each electron spin generates a tiny magnetic field. In most substances, these magnetic orientations cancel each other out since electrons pair up with opposite spins. However, in magnetic materials, the structure allows for some unpaired electrons whose spins can align parallel to each other. When a significant number of these spins align in the same direction within a region, known as a domain, they produce a detectable magnetic field. When all these domains within a magnetic material align in the same direction, the object acts as a magnet. Heating a magnet to a high temperature or hitting it hard can cause these domains to become disordered, effectively demagnetizing the object. But why do magnets have two poles? Picture Earth. It has a magnetic field resembling the field of a giant bar magnet with a north and a south pole. A magnet's magnetic field flows from its north pole to its south pole, creating a loop that envelops the magnet. These poles are intrinsic properties of magnets. When you cut a magnet in half, instead of getting a separate north and a south pole, you get two smaller magnets, each with its own north and south pole. This phenomenon indicates that the duality of poles is an essential aspect of magnetism. The polar feature of magnets brings about fascinating interactions. Similar poles of different magnets repel each other, while opposite poles attract. This behavior is described by fundamental laws of magnetism and helps to explain the underlying principles of many technological applications, from electric motors to magnetic levitation trains. While the phenomenon of magnetism is well understood at the macroscopic level, the quantum mechanics underlying the magnetic properties is an area of ongoing research. Scientists continue to delve into the subtleties of electron spin and quantum characteristics to develop advanced materials with novel magnetic properties. In conclusion, magnets operate on the principle of aligning atomic magnetic fields within a material to create a cohesive magnetic force. The existence of north and south poles is due to the nature of the magnetic field emanating and returning to the magnet, creating a closed loop. This fundamental aspect of magnets leads to the well-known behaviors of attraction and repulsion that have significant implications in our daily lives and technological advancements.